Alright, welcome to solving special systems of equations. Now you've been solving systems of equations for a little bit now. So, I know you're going to be pretty good at that. So here we have just some special cases to talk about when solving our systems of equations. So whenever we're doing this, I'm just going to give you a question saying solve this. And you got to pick the best method to solve. Sometimes graphing will be easier, sometimes substitution, sometimes elimination. Now, it's the best method for you. I have an idea what the best method is, but if you're not good at that method and you want to do this method, even if it is set up for elimination, if you want to graph it, set it up as graphing. That's totally fine. Whenever we're doing these, you're going to have two possible solutions. You're either going to have no solution, meaning there's no answer to the system, or you're going to have infinitely many solutions, which means no matter what numbers you pick for x and y, it's going to be right. So, we have some rules to go with to figure out which is which. So, here we have graphing, substitution, elimination, and the reasons for are infinitely many or no solution. So for graphing, there are infinitely many solutions if it's the same line. So if it's literally one line on top of the other line, there's infinitely many solutions. They're the same thing. No matter what you pick is going to be right. It's no solution if they're parallel lines, because we know that parallel lines never intersect. Therefore, they would never intersect to find that xy pair. Substitution. It's infinitely many solutions if as you're solving for your x or your y, you wind up with something that says number equals number, and it's the same number. If those numbers are equal, infinitely many solutions. It's no solution as if when you're solving for the x and the y and you come up with something that says number and a number do not equal each other. So if we get two numbers on each side of the equal side, they don't equal, no solution. And for elimination, it's the exact same idea. Infinitely many if we get a number equals a number. No solution if, as we're solving, we get two numbers that are not equal to each other. So let's go ahead, hop in, and do some examples. And in this video, I'm only doing examples. I'm not leaving you time to do it. So if you want, anytime I go to an example, go ahead and pause the video, try it on your own if you want. So, yeah, if you want to pause this, try this on your own, not listen to me and then follow along, that's totally fine. So, we are going to solve this. And I've already set it up for graphing, as you can kind of see, because it already both say y equals. So, I'm going to graph each of them, and they're in slope-intercept form, so I'm going to use slope-intercept form. So, for my y equals negative 2x plus 2, my slope is negative 2 over 1, and my y-intercept is 2. And I'm going to go ahead and put this in red. So this will be red. So I put my y-intercept, and then I'm going down 2, right 1, down 2, right 1. Draw my as close to being a good line as possible. Now we're going to do the slope and intercept for my right. So it's negative 2 over 1, and my y-intercept is negative 2. Now, hopefully some of you noticed already, the slope's the same. If the slope's the same, it means it's parallel. If it's parallel, it means that there is no solution. But let's go ahead and graph it just to make sure. So we put our first dot at negative 2, and we're going to go down to right 1, down to right 1. And even though it may not look like it because I'm not good at drawing, these lines are parallel, which means they're never going to intersect, which means that our answer is no solution. So the solution is no solution. Okay, so we're going to try to solve this special system. We have negative 3x plus 3y equals 4. and negative x plus y equals 3. Now you could do substitution or elimination here. It doesn't really matter. But I'm going to do substitution because this right here, this y is all by itself. It's got no number with it, which means I can solve for it pretty easily. So I'm going to solve that for y, which means I need to add the x. So I get y equals x plus 3. Now I'm going to substitute that here. So I get negative 3x plus 3. And then in parentheses for y, I put my 3x plus 3 equals 4. Now we just solve like we did whenever we did the normal substitution. So we get negative 3x plus 3 times x, 3 times x. 3 times 3 is 9 equals 4. We combine our like terms, we combine our x's, which is the only time you ever want to do that in math. Don't try doing that IRL. So we get 9 equals 4. 9 does not equal 4 though. They're not equal. So that tells us this is also a no solution. If it had said 4 equals 4, 9 equals 9, it would have been infinitely many. But because we got two numbers that aren't equal, no solution. Okay, our final example. Go ahead again if you want to do this on your own. Pause the video, try it on your own. But I'm going to go ahead and start. So I don't see any variable that's by itself really without a number with it. So a number other than 1. So I'm going to try elimination here. So I'm going to line them up. So I'm going to put my negative 10 multiplied by x below my x, minus 40y equals negative 30. And I'm going to look, do I have opposites? I have opposites with my x, and I have opposites with my y. So I have two opposites, which means regardless, I can combine. So I'm going to add these. 10 minus 10, 0, so I don't have to write it. 40 minus 40 is also 0. But because I need something to write here on the left, I am going to put a 0. I can't just leave it blank. 30 minus 30 is also 0. So when I tried to eliminate these, I got 0 equals 0. So that tells me, since this is true, that the answer is infinitely, hope I spelled infinitely right, many solutions. So here's what that means. It means that I could pick any number for x and y, plug it into those two equations, and it would make it true. Any number. Whereas with the no solution, no matter what x and y I plugged in, I would never get the correct answer. So, there's our 3 examples. Go ahead, hop to the practice problems, give these a try on your own.